And we're back, everybody. So here's the warm-up. Go ahead and pause it and play when you're ready. This is video going over section 4.3, day 2, writing equations of parallel and perpendicular lines. Now, take a look at this problem here. Write the equation of the parallel line. Now, if it's a parallel line, what do you know about the slopes of any parallel line?
They're the same.
Same, right? Slopes. Do I care about the y-intercepts?
No.
No. So if I say I want a parallel line through this, then what's the slope of my new line? 1/4. So that means I've got a slope of 1/4 through -4, comma 2. Now, that is the only new thing that we learned yesterday, right? That's pretty much it. How to tell if a line is parallel. It's got the same slope. Just as a reminder, we want to plug this into y minus y1 is equal to mx minus x1. We want to plug it into point slope form to solve for y. So let's do that. We say y minus 2 m x minus x, but remember, that's a -4, so that turns into a positive. And now we solve for y. We distribute with the 1/4. That's a fourth. 1/4 x plus 1. And then we add the 2. So y is equal to 1/4 x plus 3. How'd we do on that? Here's the deal. You need to figure that out if you don't know what you're doing, because that's going to show up a lot on your quiz on Tuesday. Okay? And so today is the last new set of notes, and it's really just a couple of slides, just talking about perpendicular lines. Monday, we will review. I'm going to give you a review sheet that we will do in class. It's not going to be like homework or anything. We're just going to do that in class together. And then Tuesday is going to be our quiz. Wednesday, I'm not planning anything groundbreaking on Wednesday, just because I know a lot of people take that day off anyway. I am basically using that day as like kind of like a catch-up day. If you need to turn anything in, get any homework done, do anything you need to do, we're going to do it on that Wednesday.
Party day?
No. So I said
I'll bring pizza.
no.
Party.
Pizza at 8:45 in the morning.
Yes.
No.
I don't
Ain't
want
going.
pizza.
Quiet, please. Quiet, please. Yes, it.
That Wednesday was Thanksgiving.
No, Thursday's Thanksgiving.
It's Thanksgiving.
Like
Yeah, we have
Thursday,
school on
Thanksgiving,
I'm not going.
TH,
I did it for Florida.
Thanksgiving.
Yeah.
Oh,
Yeah.
it's the parade this year?
I just had
Are they
somebody.
having the parade this year?
Are they doing the Macy's parade this year?
Yeah.
I will be
Frick yeah.
That's on Thursday,
That's the
because
Thursday.
Thanksgiving is
Oh,
on.
yeah, I'll be gone on next week.
Yo,
Yeah.
what the?
No, you're not.
Where's my water
No,
bottle?
you're not.
Yes, I am. I have family in New York.
Tommy's
No, you're not.
He's from New York.
I don't believe you.
New
say
York.
that.
Take my water bottle.
He's from
I'm from
Minnesota.
No, you're not.
Bro, you don't see my
If I call your mom right now, will she verify this?
Yeah.
Please call her.
Because she's
They
verified.
are.
She gets jiggy with it. She's verified.
Put her on
I'll do that.
speakerphone.
She's valid.
I'm
He's
videoing
old.
this.
I'm from New York.
So
He's valid, bro. He's from
What part of New York?
Huh?
What part of New York? Queens? What's the address?
I don't know. It's my cousins.
Where does your cousin live? What school does
New
your
York.
cousin go to?
What school do they go to? I have no idea.
The school in New York.
I don't-
Bishop
New
York
Sycamore.
High School.
That's
Well, I don't go up and ask. I don't go up and ask.
982.
It's so elaborate. Look at my water bottle. I like flipped it and like I missed.
How about that? So moral of the story here is we're gonna have a quiz on Wednesday or quiz on Tuesday.
And there's
Shh, shh. That quiz is one of only 2 quizzes left for the 9 weeks. Okay? So those of you who need a grade boost, this is one of your last chances. Why is that so? Well, because think about it. When we get back, we have a week and a half. Okay? What we're going to do is we're going to learn sections 5.1 to 5.3, and we're going to take a quiz. And that's going to be it for when we start reviewing for exams. Okay? So just know that there's this quiz next Tuesday, and then there's going to be a quiz when we get back, and then we will have to do exams.
I don't know how exams work. You probably seen this. I was still listening. So, like, do they like affect like your actual grades, like report?
20%.
Yeah, it's 20% of your semester grade, 10% of your overall grade. Okay? So, because people always ask me, like, okay, what does it factor into? Like, how does it affect your 9 weeks grade? it does not affect your 9 weeks grade. It affects your overall grade for Algebra 1. So like, if you, like, it affects your GPA, basically. Okay, it's one test that affects your GPA. It affects it directly. Basically, you can think about it like this. Because 9 weeks is worth 20% of your overall grade. So one exam is kind of like half of what a 9 weeks is worth. Okay, which is a lot. You guys are gonna find this in college too. I had a calc class one year, one time, where there was 2 grades for the entire class. Not homework grades, no nothing. It was just 2 grades: the interim test and then the exam. That was it. 2 grades. If you failed the interim test, you should drop the class because there was no getting a passing grade on the exam and not on the interim test. Okay, so exams aren't going away. You're probably gonna have them again in college and so on. The rest of whatever. If you're going to college. Okay.
Why would I want to win?
Money.
Yeah, you can just find my house.
What's money, man?
Yeah, it's nothing. Become a truck driver.
Just become a teacher. You don't care about money.
Just work at like McDonald's or something.
I mean, hey, you do you.
Hey, man, money's money.
They're hiring. Eh? Probably. Anyways, shh. Let's talk. Are there any questions on the homework? Hopefully we did okay. I can go through any of them if you need to. Yeah. Give me one of them, 7 through 10. Let's do 10. How about that? Okay. And then because honestly, 7, 8, 9, and 10 are the exact same problems, right? So let's think about how we do these problems. It's exactly like the warm-up that we just did as well. Let's take a look at 10. Take a look at this equation. 2y is equal to 3x plus 10. I want to take that equation and get the slope from it. How do I figure out what the slope is? How do I figure out, is the slope 3?
Yes.
Wait,
No. Because y is not completely alone. Y is not completely alone on the left side. So I have to divide by 2 over to the other side. So what is my slope now? 3/2, right? 3 over 2. My slope is 3 over 2. My point is 2 comma negative 5. Where did I get that? Well, it told me in the problem. Okay, now from this point, I put it in a point slope and solve for y. Y plus 5. Brennan, cut it. X minus 2. Distribute it with the 3 halves. Y plus 5 is equal to 3 halves x minus 3. Subtract the 5. Y is equal to 3 halves x minus 8. Does that make sense? That's the process for every one of them, 7, 8, 9, and 10. And I'll tell you right now, there are several of those on the quiz next Tuesday. That's a majority of the quiz. Taking a point, taking a slope, and making slope-intercept out of it. Yeah.
If there's no more questions, can I go to that?
Sure. Even if there are more questions. Yes.
Brendan, cut it out.
I'm just confused a little bit on the right side of the
Yes.
board. How did we move the 5 over?
That's point slope form.
Oh.
That is that y minus y1. This is Monday. Y minus y1 is equal to, Tuesday. X minus x1. Okay? So you put the x in where the x goes, the y in where the y goes, and the m in where the m goes, and then you just solve for y.
Oh.
Okay, let's get to today's notes, because we do a lot of the same here in today's notes. Let me pass you out the guided notes for today. So yesterday, we talked about parallel lines. We said they had to be the same slope. Today we're going to talk about perpendicular lines. Can anybody tell me, what is a perpendicular line? Or what is a set of perpendicular lines? Right angle, something. They intersect at a right angle. What's that? Yeah, kind of how like the axes are. Yeah.
With toddlers and Josh.
So perpendicular lines are lines that cross at a 90-degree angle. Quiet, please. Perpendicular lines are lines that cross at a right angle. Let me show you an example of them. Okay? Take a look at the red and the blue lines that I have on my screen. You have them right there in front of you as well. They're just not red and blue. Y is equal to negative 2x plus 2. Y is equal to 1/2 x minus 1. Okay, let me ask you. Do I care about the y-intercepts? No. Not in this case anymore, or not in this case either. Like I didn't care about them for my parallel lines. I don't care about them for my perpendicular lines. Those don't play a role. What plays the role is the slope. Take a look at the two slopes that we have. I have negative 2 and a positive 1/2. I have a negative 2 and a positive 1/2. Let me show you a couple more examples of lines that would be perpendicular and their slopes. If I had 3/4 and negative 4/3, those would be perpendicular. If I had 5/7 and negative 7/5, those would be perpendicular. If I had 4 and negative 1/4, those would be perpendicular. Can anybody tell me a pattern that you see?
One is positive and one is negative.
Good. One is positive, one is negative. Good. What else?
They're both completely opposite.
What do you mean by that?
They're both flipped around.
Flipped. They're both flipped. What is that term? Being flipped in a fraction is called the reciprocal. Reciprocal.
And like they always have to have like one of the numbers on the left has to be on the right too.
Okay, yeah, because what happens is it goes top to bottom, right? The same numbers have to be there. I'm not changing the value of the slope at all. What I'm changing is the orientation of the numbers. Like for example, I see a positive 1 here and a negative here, a positive here, negative here, positive here, negative here. That is called the opposite. So these slopes are called the opposite reciprocals. These are called the opposite reciprocals of one another. Positive 4/3, positive 3/4, negative 4/3. Positive 5/7, negative 7/5. Positive 4, negative 1/4. How are these reciprocals? Because if you flip 4/1, it turns into 1/4. Okay? So this is the pattern that you should see. If two lines are perpendicular, then you should see this happening in their slopes. So this is kind of a change from yesterday because yesterday, man, for two lines to be parallel, all you had to check to see if it was the same slope. This requires just a little bit more thinking because it's not just the same number, they're opposite reciprocals. Okay, let's see how this is going to work. Just like what we had yesterday, I'm giving you 3 equations. There's one of the lines that's really easy to tell the slope. Which one is it and what is the slope?
Be line A and the slope is 4.
Yeah, line A is really easy because y is already alone. So my slope is 4. Let's check line B. Let's get y completely alone. Meaning subtract the x to both sides. And then divide by 4. So y is equal to, now remember there's a 1 sitting out in front, right? Negative 1/4 x plus 3/4. Plus I don't care, right? I don't care about the y-intercept. I only care about the fact that the slope is negative 1/4. Let's pause for a moment and not say anything about those two lines. Let's talk about line C. Let's solve this one for y as well. this would require adding the 2x to the right side. So we got negative 8y is equal to 2x plus 16. And then dividing by negative 8 to each part on the other side. So y is equal to, now can I leave it as 2/8? No, it's got to be 1/4. 2/8 reduces down into 1/4. And it was negative minus 2, but it doesn't matter. There are a couple statements that I could make. What is one conclusion I can draw from all of this? What's that? Line B and C are parallel. Good. B and C are parallel. Sid?
Wouldn't you be able to say that C or B is perpendicular to A because you would put 1 underneath the 4?
Yeah. Take a look at the slope for line A. Take a look at the slope for line A. Isn't that like 4 over 1? So if I flipped it, it would be 1 over 4. And this is positive, so the other one must be negative. Negative 1/4. And it's opposite reciprocal. Now look. Aren't those two both the same slope? So we can say this. Not only is A, and here's the symbol that we're going to use. We're going to say A is perpendicular to B. That's the symbol for is perpendicular. Upside down T. And A is also perpendicular to C as well. So I can make 3 conclusions from this. B and C are parallel to one another because they have the same slope. And A and B are perpendicular because they have opposite reciprocal slopes. And because B is parallel to C as well, A is perpendicular to C. Let's take a look at our next one. Now, for this one, I'm not given the equations, am I? I'm given 2 points. Can I still find the slope?
Yeah.
Sure. Let's find the slope. Just as a reminder, the slope formula is y2 minus y1 over x2 minus x1. So let's find the slope for line A. Okay, so the slope for line A is 3 minus 1 over 0 minus negative 2. 3 minus 1 over 0 minus negative 2 gets us 2 over 2, which ends up being 1. So the slope is 1. Line B. The slope is 4 minus 1 over 6 minus 4. Okay, 4 minus 1 is 3. 6 minus 4 is 2. 3 over 2. Do you have a question, Sam?
No, you get that one.
Okay. And then line C, the slope is 1 minus 3 over 4 minus 1. Now take a look at what happens with line C. 1 minus 3 is a negative 2. 4 minus 1 is a 3. Let me ask you first. Are any of these lines parallel? No. So Sid, what can I say?
Line C and B are perpendicular.
Good. We can make this statement. B is perpendicular to C. Or we could say C is perpendicular to B. That doesn't matter. Order doesn't matter. How do I know that? Look at 3 and 2. Do you see how in line B it's 3 over 2? Do you see how in line C it's 2 over 3? And one's positive and one's negative. They are opposite reciprocals of one another. So I know that these lines are perpendicular. So that was seeing if lines are perpendicular or parallel. Let's do that same thing where we create the equation. This is just like what we did in the warm-up. Except now I'm not saying parallel, I'm saying perpendicular. Okay, let's take a look. What is the slope of my old line? 1/2, right? So and now, here's what I'm going to do. I'm going to say old is 1/2 because I have to do something to that slope, don't I? I can't just take that slope and use it. That would be a parallel line. I've got to do something to that slope. So I'm going to call it old and transfer it into something new. What is my new slope?
2 over 1.
You're close.
-2.
-2 over 1. Which ends up just being a -2, right? Because I took 1 over 2, I flipped it to get 2 over 1. And 1's positive, so this new one has to be negative. -2 over 1, which just reduces down into -2. So now our slope is -2 and our coordinate is -3, 1. And this becomes like a problem that we could have done the past 4 days now. Given a point and a slope, let's make our line. Y minus y1 is equal to m x minus x1. Y minus 1 is equal to -2, x plus 3. Catch the plus sign there. It would be minus a -3, so it's a plus 3. Yeah.
So it's always the last coordinate that goes first.
Yeah, because it's y minus y
Okay.
equals m x minus x. So now let's distribute the -2. So y minus 1 is equal to -2x minus 6. So y is equal to -2x minus 5. That line is perpendicular to that line. That new line is perpendicular to the old one. And I know it runs through -3, 1. Yeah.
Where did the +1 come from?
Just to get y alone. It
Oh.
was y minus 1, so I got a +1 to get y completely.
Why wouldn't we like do +1 for the 2x, the -2x too?
Because those are not like terms. This isn't like a 1x. Right? Whenever I add just a constant on the end, I just add it to the constant on the other side.
Sure.
Okay. Questions here? Okay, let's take a look at our last one. This one's a little bit more difficult. Just a little bit more work on the front end. Because look at my equation. Is it already set up to see my slope?
No.
Please don't just say the slope is 8. You guys, all the time it happens where people just look at the x and like, oh, there's a slope. No, it's not solved for y yet. You can't do that yet. So let's solve this equation for y. Let's get y completely alone. Subtract the 8x. Get the x over. So -2y is equal to -8x plus 2. And we divide by -2. So y is equal to 4x minus 1. Minus, I don't care, right? -8 divided by -2 is a positive 4. Okay, now, the slope is 4. The old slope is 4. What's my new slope then, Tommy?
1/4.
You're close.
-4. 1/4.
-1/4. Right? That is my opposite reciprocal. Going from old to new is my opposite reciprocal. One's positive, the old's positive, the new's negative. 4 over 1 becomes 1 over 4.
Could it be the other way around? Like the old is -4 and
then the new would have to be positive.
So how'd you get -1/4?
Because
Okay, take a look here. This was 4 over 1, right?
Yeah.
So it becomes 1 over 4.
What's the point of doing the whole equation if we can just flip it?
Because we needed to figure out what that was.
we didn't have it.
We didn't have it yet. We needed to get y alone so that we could figure out what the old is, so then we could flip it to find the new. Now we take our point. So now we've got the slope is -1/4. The point as 4 comma -3. And now we plug it into find point slope form. So now we have y plus 3 is equal to -1/4 x minus 4.
Why would it be +3?
Because you're switching.
Okay.
Thanks, Tommy. Appreciate the help there. And now let's solve for y. Let's distribute in the -1/4. -1/4 x, negative times a negative is a positive. 1/4 times 4 is a 1. And then I subtract the 3. So this becomes y is equal to negative 1/4 x minus 2.
We're done, we're not.
We're done.
Well, I mean, with the same problem, I'm like, okay, this is the last time.
Okay, negative 1/4 x minus 2. That is the line that is perpendicular to the old line that goes through 0.4 comma negative 3. Okay, I'm going to stop the video here. Hopefully this actually saves.